In this video, I'd like to talk about parallel and perpendicular lines. So here we have two lines that are parallel, and remember that parallel lines extend indefinitely and do not ever cross each other. So if we look really far off in this direction or this direction, we won't see these crossing each other. And perpendicular lines, these are two lines that cross each other, they intersect each other at a right angle or at an angle that is equal to 90 degrees. So the way that we write that two lines are parallel is that line AB is parallel to line CD. So we use this symbol here, which is basically just two parallel lines. And when two lines are perpendicular, we can write that line EF is perpendicular to line GH. And again, we're using a symbol that accurately describes what's happening here. These are two lines that are intersecting at a right angle. And what we want to do is focus on the equations of these lines and how they relate to each other. So let me just make a little bit of room. And remember that the equation of a line can be written in several different forms, but one of the forms is called slope-intercept form, where the equation is solved for y and is equal to m multiplied by x plus b, where we would graph this on the xy coordinate plane, and m is the slope of the line, and b is the y-intercept of the line. This is where the line crosses the y-axis. And slope, we can define that in several different ways. And the simplest way is that slope is how much the line rises. So we can say the rise of the line divided by how much the line runs. So divided by the run of the line. So rise has to do with the y values. So another way to look at this is we're wondering how much the y values change. Remember when you see this delta here, that this just means change in. So the change in the y values divided by how much the x values change, or the change in the x values. Whereas the change in the y values we call the rise, and the change in the x values we call that the run. So this is one way to write the equation of a line. And when we write the equations for parallel lines, what we can notice is that these lines have the same slope or the same steepness, since slope is really just a measure of how steep the line is. And parallel lines have exactly the same steepness. Whereas perpendicular lines are a bit more complicated. So these slopes, we can say, are negative reciprocals of each other. So negative reciprocals. Now, one thing you can notice is that if one of these lines has a positive slope, the other one has to have a negative slope. So if one is generally going up, the other is generally going down. So that's where the negative comes in. And remember that reciprocal is a fraction that's flipped over. So let's say that for one of these lines, that the slope we'll call m1 is equal to 2/3. Then the slope of the other line, which we can call m2, we take the reciprocal of this and we take its negative. So it would be minus this fraction flipped over, which would be 3/2. So another way to write this is that the slope of line 1, or m1, is equal to the negative reciprocal of slope m2. So we flip the slope, we can put a fraction or a whole number over 1, and then flip it, and then take its negative. So we flip it and take the opposite, and that's equal to the slope of the line that's perpendicular to it. And one other way to see this is that if you multiply each side of this equation by m2, you get that the product of the two slopes of these perpendicular lines is equal to -1. And in general, it's a bit more complicated to understand the slopes of perpendicular lines and why they are like this, but we'll look at a proof in a later video. For now, you just want to get comfortable using this idea. So let's look at an example or pair of examples from each of these cases. And for parallel lines, let's say our example is that for, let's say, line 1 is equal to 7x plus 2, where 7, the number multiplied by x, that's our slope, and 2, the number added at the end, this is our y-intercept. And for line 2, y2, it would have to have the same slope. So the number multiplied by x would also be 7, but its y-intercept could be anything else. Let's say minus 11. So remember, y-intercept is just when you plug in x equals 0, and then the y value is equal to whatever you're adding or subtracting at the end. So parallel lines are fairly straightforward. They have the same slope. But again, perpendicular lines are a little bit more complicated. So let's look at some examples of these, where let's say we have line y3, and we can say this is equal to minus 5x over 4 plus 1. So if we had a line that's perpendicular to this, which we can call y4, then the slope of this has to be the negative reciprocal. So it would be a positive number, and we flip the fraction. So positive 4x over 5. And again, the y-intercept can be anything here. So let's say minus 3. So these two lines are perpendicular. And again, we can write it that y3 is perpendicular to y4. And over here, these two lines are parallel. We can say that y1 is parallel to y2.